the next series of videos, I'm going to break this down into maybe 2 or 3 different videos. I'm going to go over the concepts of energy, heat, pressure, work, pressure, volume, work, and enthalpy. So this is going to, these video series are going to cover the material from chapter 5 on energy and thermodynamics. So the overarching topic that we are dealing with in this section is energy. And as Einstein's famous equation, E equals mc squared, tells us, energy is everything. Energy is mass. Mass is energy converted into mass. And mass makes up matter. Matter is everything that has mass and occupies volume. So energy is essentially everything. At the same time, we don't really truly understand what energy is at all. And that right there is a crazy, mind-blowing concept for you to ponder late at night or over coffee with friends or right now on a video chat with someone else in the class. But for right now, we are going to simplify the concept, and for general chemistry, we are going to define energy as the capacity to do work or produce heat. We may be used to seeing a capital E to represent the concept of energy, to represent energy. However, if we follow the convention that most chemistry textbooks use, E is actually representative specifically of the energy of the universe. And studying the energy of the entire universe would be really complicated. Usually we are interested in studying the energy of a system, the particular thing that we want to study. The system could be a chemical reaction, it could be an object, it could be a few objects, it could be a process like the evaporation of water. Whatever it is that we are studying, that is the system. And then the rest of the universe becomes the surroundings. So we always break things down into the system and the surroundings. And so when we study energy and energy changes in this section, we are typically going to use the symbol U, which is the energy specifically of the system rather than the energy of the entire universe. Energy is the capacity to do work. Work, which is abbreviated with a lowercase w, is force applied to move an object. It could be the force required to push a box across the floor. It could be walking up a flight of stairs, which, if we are Seton Hill folks, we are really familiar with. Or it could be a sample of gas expanding in a container that causes a piston to rise. This last example is an example of pressure volume work. This is work, an object being moved that is accomplished when a gas's volume changes. When its volume increases and pushes up against another object, causing that object to move. The equation for pressure volume work is W equals negative P delta V. P in this case stands for pressure and usually in units of ATM, and it refers to the external pressure. So if we go back to that previous slide and we had that piston expanding, it's not the pressure of the gas inside the container, it's the pressure of the gas on the outside of the container. Delta V is the change in volume in liters, and change is always final minus initial. The change in volume can end up being negative. That would be the case if the gas contracts. The change in volume can end up being positive. In this case, the gas would be expanding. It's really important to note that this can be positive or negative, and that's going to impact what work ends up being. So if the delta V is negative, work will end up being positive. If delta V is positive, then work will end up being negative. When work is positive, that means that the system received work or had work done onto it. And this would correlate with the volume of gas in the system getting smaller or being contracted. If work is negative, then that means it released work, it did work, and that would correspond to its work being negative and the gas inside expanding. All right, at when you use this equation, work equals negative P delta V, your units will come out to be ATM liters. Work is a type of energy though, and so we typically express energy in joules. So we can convert ATM liters to joules using the conversion factor ATM liter is equal to 101.3 joules. At this point in time, I'm going to stop the video here and give you a chance to try the worksheet problems, chapter 5 worksheet. It's uploaded onto Canvas, and if you were in class our last day, you also have a paper copy of it. You can solve some of those problems on there that deal with pressure volume work and check your answers against the answer key posted on Canvas. And there are also some video solutions posted on Canvas. I will continue in the next video with the concept of heat.